Hey guys, so today we will be going through the third subject of the week. This is quite a bit of a complex subject, at least for me, but I hope it's not as complex for you guys. But I hope by teaching you, I can learn a lot more myself. So, the module is 1030, which is data, it's a bit thick, data communication and network. So, the first thing that we learn is the difference between digital data and analog data. So, analog data is essentially data understood by humans, right? And digital data is data that is understood by machines. So, that is a very important distinction to make. So, machines cannot understand human data, and humans cannot understand machine data. It is impossible unless you are an android. Maybe Sophia can do that. Yeah. Yeah, Sophia can do that. Fuck that. Anyways, so for communication, there are five important parts of communication. One, there must be a sender, right? I mean, obviously, you can't communicate without a goddamn sender. So the sender must have a receiver. Obvious, pretty obvious. And they should send a message, right? That is also obvious. So, along with that, there is something known as the transmission medium. Now, right now, if I think about my situation, I am speaking to the air. So that is the first transmission medium. It is going to my mic, and my mic is transmitting that, taking the something, and it's transmitting that at the computer. The computer uploads it into my software somehow, and then I upload it into YouTube. And after uploading to YouTube, YouTube sends it to your computer sends it to your speaker, and it comes back to the air and through your ear. That is transmission medium, essentially, the simplest version of it. And finally, last but not least, something known as protocol. Protocol is essentially a set of rules that ensures that the message is sent so that the receiver can understand it with good quality. I mean, it's simply a set of rules that ensure that the message gets sent, right, in good, clearly, and good quality. So, when we have a message, right, what is a message? Well, a message can consist of anything. It can consist of text, it can consist of numbers, it can consist of an audio, it can consist of a video, and it can consist one more thing. What is that? Images, right? So a message is essentially one of this or a combination of this, right. So now let's take a medium. So a medium, transmission medium, is essentially stripped into two, which is wired and wireless, right? Wired can be again programmed into two, which is current or electromagnetic. Now, what is this? Well, obviously, we can have a wired connection from place to place. Mainly wired connections use voltage, 0 to 5 volts. Most of them use current. But what about our fiber optic cables? They use electromagnetism. They use light, which is a part of an electromagnetic spectrum. And then there is wireless. This is a very important distinction you need to make. Okay? Right. So, how is a message sent through wireless media? How is message sent through wireless media? It is something known as packets. Packets is essentially you take one entire data and you break it into small pieces. And each small piece is known as a packet. So a packet is a small chunk of the data being transmitted. If you can't understand my handwriting, I am so sorry, but you should be able to take your own notes with this. Anyways, moving on. So, along with this, we learned something known as network types. Network types. So, what are network types? Well, the simplest network type is known as a personal area network. What is a personal area network? Well, it is essentially a set of networks within a 1 to 5 meter radius, right? It can be used in a home, it can be used in a gaming setup. Now, right now, most people have a personal network. For instance, I have my laptop, I have my keyboard, I have my touchpad, I have my mouse, I have connected my computer to the power cord cable, I have connected my computer to my phone. This is what a personal area is consisting of. Then there is local area network, that is ranging from 10 to 200 meters. Now, a LAN is also used in a home. It can also be used in an office. It can also be used in one floor. Right? It is a set of like interconnected devices. All these are interconnected devices that within this specific radius. This radius is the one who mainly defines. What kind of network it is. Right. Next, there is campus network. Now, when I learned IT during grade 11, I only knew that there were 3 types of networks: LAN, MAN, and WAN. Now there's 2 more: PAN and campus network. So I think I can refer to this guy as CAN, but it just feels wrong. Anyways, campus network is from 1 to 10 kilometers. I believe I'm correct. Yes. Okay. So this is a set of interconnected LANs. In one site. Now this is very important. This is one site. Right. Then there is MAN, which ranges from 10 to 1,000 kilometers. No, it's not 1,000, my bad. 50 kilometers. This is a set of interconnected LANs, same thing, in one city. Right? Whoa. Too much. Going too much, mate. Too much. Next, last but not least, we have WAN. This ranges from, I believe it's yes, this is 10 to 1,000 kilometers. This is a set of interconnected devices all over the world. There are many ways you can connect it. So the internet is one of the many examples for WAN. MAN, well, this is used by internet service providers, ISPs. Campus network is as used in an office building or in a campus building in one site. LAN is used in one floor or one room, whereas PAN is for only one person. Next, we have something known as topologies. First topology which we must know is point to point. Point to point is if 2 devices connect to each other with one link. Only these 2 devices connect to each other. What's the point? Well, you will have dedicated connection between these 2. That's a good one. but it is only one connection, right? So it's not practical to use in many scenarios. Sure, you can connect to your sister's computer, you can connect to your mother's computer to help her out whenever she wants to have her problem solved, but otherwise, point to point is just that, just two devices connected to each other. Next, we have bus topology, right? Bus topology is a set of devices connected to one main bus, right? So this has also one link, and it has two terminators in each end, right? So that the message gets sent. It is usually used in offices, and it has a lot more bad than good, but it's also used in CPUs as well, right? Because I mean that is one of the practical applications, because you want every piece to get every information. But otherwise, it is used in such a way where if one line breaks, the entire thing is broken. And if, let's say, computer 1 needs to send something to computer 4, computer 2 and computer 3 will also always hear it. So there is no privacy there. Okay. Next, we have ring topology. So it's a bunch of devices that are connected through a ring. So these are all essentially point-to-point networks, right? But they are all connected in a loop. So there are two types of loop. Most loops have a single round. So if this is the clockwise round and I need to send to computer 3 by being a computer 1, it will first pass computer 2 and then it will go to computer 3 and then it will come back. So unless it is a dual type, so dual type means the information can go on both ways. So unless it is one of this, if this is broken, the complete system is broken. So ring topology uses the help of repeaters. So these are all connected to a specific computer. So what a repeater does is it takes the information and sends it around with enough of the information repeated. So a specific way to put this is a repeater's function is it takes a signal, amplifies it so that the information will reach the next repeater. Please type this for yourself. I'm not going to write this entire thing out. Next one is known as star topology, or hub and spoke, I guess. I'm not sure. So many computers will connect to, or devices, I should stop you saying the word computers and start saying devices, connect to a single switch or hub. So if I need to send information to this computer from computer 1 to computer 2, it will first go through the switch and then it will go back to device 2, right? So the bad news about this is that if this switch breaks, the entire system is shut down, right? And secondly, it is not scalable. It is very hard to scale it, and it's also expensive. It's expensive, right? Next, you have the tree topology. Oh, by the way, I forgot about links. So this point-to-point has one link, bus topology has one link, ring topology has the number of devices connected is the number of links. Star topology also has number of devices. Tree topology has definitely more links than number of devices. And tree topology is essentially some devices are connected to one switch, which is connected to another switch, which may be connected to another switch, and so on and so forth. Last but not least is the mesh topology. Now, a mesh topology is, let's say you have 5 devices. Every device has a dedicated connection to every other device. Now, the good news is all devices are connected, so it is very fast, but the bad news is it is expensive. Oh, also it's very reliable. Like if you have one line that is cut, all the other things work. So if every single device is connected to every single place, it is known as a full mesh. If not, it's a partial mesh. Right. So the number of links in a mesh is n times n minus 1 divided by 2. Okay, so this is the number of links in a mesh, in a full mesh. So a partial mesh will always have less than this number of links that is less than this. Right. And now we have finally 2 more topics, which is data flow. So there is a simplex data flow, which is only from data only flows in one direction. Data flows in a unidirectional form. Then there is half duplex. So an example for simplex is TV. Half duplex means the data can travel in both directions, in 2 directions, that is bidirectional, but it can only do it one at a time. Then you have full duplex, which is data can travel in both directions at the same time. Right? So a good example for half duplex is a walkie-talkie, and a good example for full duplex is our normal telephone conversations. My bad. I'm not going to do that. It's ugly as hell. Next we have something called unicast. Unicast is from one sender to one receiver, right? And then we have broadcast. There's an A there. From one sender to all receivers. Then we have multicast. From one sender to selected receiver. And then we finally have anycast, which is from sender to nearest receiver. Right? Okay. So these are all the things that we have that has been taught in my lecture. And now I'm going to be teaching you things that I learned personally. So again, disclaimer, I may be wrong here. And if I'm wrong, please feel free to correct me down the line. So I personally learned circuit switching and packet switching. So circuit switching is essentially circuit switching is meant for voice and packet switching is meant for data. So two devices have to be connected for circuit switching to happen all the time. So the bad part about circuit switching is all of this is lost capacity if it is not used. Right? But that is the downside. The upside is that it will always deliver. Right? We don't have to worry about, now let's say the data connections, all the towers are down. Well, the landline will always work. That is what's known as circuit switching. Packet switching is the routes. It's not a specific route. These are routes that packets decide to take. Right? These are routes that packets take. Now, there are 2 types of way. There is the datagram approach, and then there is the virtual circuit, right? So, datagram approach is The packets decide to take any route they wish, and they may come to this destination out of order. Whereas virtual circuit, the sender and receiver establish like a virtual specific line, and all the packets travel in that specific line in a specific order. Okay, so that is circuit switching and packet switching. Next, we have something known as broadband, broadwidth versus throughput. So, broadwidth is something like a big tube, right? But throughput is the actual amount of water that is coming out of the tube. So, I'm going to give a simple example. Broadwidth is your full potential capacity. If you work at 100%, the you that you can achieve, that is broadwidth. But in reality, you are doom scrolling on your phone and not studying and doing all this other BS shit and not being up to your full potential. That is throughput. I'm sorry if I hurt your feelings, but that's the truth. You gotta lock in, babies. You gotta lock in, boys and girls. Come on. So, usually, the problem with this, like, if broadwidth is your capacity, right, your full capacity, your full potential, but throughput is reality. Why is reality different from capacity? I mean, data packets, they do not have any other work to do. All they have to do is travel from place to place. Well, there are things called as transmission delay and propagation delay. So, transmission delay is essentially the number of bits divided by speed, whereas propagation delay is the the length of the link divided by the distance, right? So these two will always be the reason why there will be a throughput when there can be a full, more better version of all this stuff, right? There'll always be a throughput. There'll always be a few hurdles. There'll always be some things around the way, right? So I think that is all for this subject that I have learned. This is all the things that I learned this week. So this is the theory that I learned this week. So I think we should stop from theory and we should go on to the practical, the labs. Labs is Cisco Packet Tracer. Now, there are many YouTube tutorials on how Cisco Packet Tracers work. So Cisco Packet Tracers are used for the sake of emulating networking without having all the needed requirements. For instance, this is a logical way to think about this, and then there are physical ways to think about this. Oh my god, I have never seen this. So the logical thing is if you look at here, there are many devices, right? So there is N devices that gives out so many devices in your home, in your smart city, in your industrial, in the power grid. There's components, which is boards, actuators, sensors. There's connections. So I don't know if you guys. Okay, look at this. So this is the console connection. This is the copper straight through. This is the copper crossover. This is phone. This is coaxial. So on and so forth. There's miscellaneous, which is some laptops and PCs. This is the internet, the remote network. These are routers, all different types of routers. These are the different types of switches. These are different types of hubs, so on and so forth. So essentially, we can use this to emulate what a networking system may look like. So say I have, I'm going to pick something that I know, that I have experiences with. So I'm going to pick a PC. So let's say I click on this. Look at this. So this is the logical view, right? I can add or remove any module. I can change any of this. I can connect it to any way I wish. So these are the many various types of things that I can do. So this is essentially to emulate how some things may work. Now I may have two PCs, I may have a laptop, I may have a server, I may have a phone, a TV. So then I can connect them in any way I wish. Hello. Sorry, yeah. Okay, so I have all these devices that are right here. So I can connect it. Okay, I can't connect this to this. I can't connect this to this. Oh no, what can I do? Well, how about I connect PC to PC, and then I connect PC to laptop. Oh, it cannot be connected to the port, and then I connect. Oh, I can't. Fine. So there are many ways I can do this. So essentially, this is to emulate how systems work. So I'm not going to say. Second off, what we learned in this lab is Wireshark. Now, I absolutely hated this because there are so many things that happen here because they haven't taught us a lot and I had to learn a lot. And so right now I'm going to teach you something which is something that I had to learn. So whenever you send a message to someone, right, there is something that you have to always, teach the other person. So the reason why what I want to teach you here is that whenever you send a message to some person, there is something called the protocol, right? Now remember I told there is a protocol that we learned initially in the previous part. So protocols are something like the things that help the message to pass through. So there is no specific thing to find the protocol, the amount of the protocol size in this thing. So the only way you can find protocol, now I'm going to take a specific one. So look at this. So if I take this, Ethernet will always have 14 bytes, right? IPv, the protocol header length is 20 bytes, right? And TCP header length is also where is it? 32 bytes, right? So 32 plus 20, 32 plus 20, 52, right? 52 plus 14 makes 66. 66 bytes is the protocol length, right? The total header length. And look at this. So the transmission protocol is 717 bytes. So the packet length is 783. If we take the calculator, which, oh my god, I don't have the calculator here. Here it is. Bang. So if we subtract 783 minus 717, we get 66. That is the amount for the protocol overhead. So I just had to learn this. I'm just saying this because I had such a hard time finding what this is, and after such a long time I found it out. So that is all for DCN, DNC, whatever. I hope you have a great day, and see you all soon.